Good morning to everyone. WE8591 Digital Signal Processing, third year, fifth semester, Triple E Department, Regulation 2017, Unit 1 Introduction. So, in this digital signal processing, we are going to see about the introduction of digital signal processing, the classifications of system, continuous time and discrete time, linear, causal, stability, dynamic, recursive, time invariance, variance, continuous and discrete energy and power signal, the mathematical representation of a signal, spectral density and sampling techniques, and quantization error, Nyquist rate, and aliasing effects. So in this unit 1, we are going to concentrate the various classifications of signals and systems and sampling and quantization and Nyquist rate and aliasing. So the outcome of the digital signal processing subject is the ability to acquire knowledge on signals and system and their mathematical representation, ability to understand and analyze the sampling and quantization techniques, ability to analyze the aliasing effects. So what is meant by the digital signal processing? The digital signal processing is a process of analyzing and modifying a signal to optimize or improve its efficiency or performance. It involves the applying various mathematical model and functions to that processing of that signals. So in that analog input, we are giving that analog filters. That signal will be a band limited signal. The analog signals will be converted into a digital signal. That digital signal will be processed and will be reconstructed at the receiver side. So it's a general process of that DSP, digital signal processing. So what are the application areas of digital signal processing? These are all the image processing, speech, audio, telecommunication, echo cancellation, speech recognition, pattern recognition, animation, equalization, data communication, video conferencing. So what are the real-time applications of digital signal processing? Means the image recognition, pattern recognition, fax, printers, and the robotics. These are all the applications of digital signal processing applications. So what are the advantages? It is have a high accuracy and it will be accuracy compared to analog filters. So it will be implementation of compared to analog counterparts. So it's difficult in analog system as the entire hardware and its components needs to be changed. So what is mean by a signal? Signal is a physical quantity that varies with the time. So it may be depend on independent or dependent variables. So what is mean by the one-dimensional variable? When a function depend on a one single independent variable to represent a signal. So when function depend on two independent variables, that's called two multi-dimensional signals. So what is meant by that? Input signal means a signal that enters a system from an external source is referred to as input signal. So output signal, a signal produced by a system in response to the input signal, is called output signal. So what are the classifications of the signal? Continuous time, discrete time, periodic, aperiodic, even and odd, deterministic and random, energy and power signal. What is a system means? A system is an entity that manipulates one or more input signal to perform a function which results in a new output signal. So what are the classifications of system? Continuous time, discrete time, stable, unstable, memory and memoryless, invertible and non-invertible, time invariant and variant, linear and non-linear, causal and non-causal systems. So what is meant by the continuous time signals means a signal x of t is a representation if it is defined for all the time. The amplitude of the signal varies continuously with the time. In general, all the signals by nature are continuous and continuous time signals. What is meant by the discrete time signals? Most of the signal sources, such signal have to be discretized since the processing done on the digital computing is digital in nature. A signal x of n is said to be a discrete time signal if it is can be defined as a discrete instant of time n. What is meant by the deterministic signal? A deterministic signal, if there is a no uncertainty with respect to its value at any instant of time or signal, which can be defined as a exactly known as deterministic signal. Non-deterministic signal, non-deterministic if there is uncertainty with respect to its value at some instant of time. So non-deterministic signal are random in nature, hence they are called random signals. So these are all the example problems about that causal and non-causal. How to find the causal and non-causal means if the condition means the output depends on the present and future inputs, it's called non-causal. If the present input signals in the sense if the past present and the future values in the sense, that is called a non-causal. So present value in the sense it's called causal signals. So likewise we have to put y of 0, y of 1, y of minus 1. If you put in the sense we have get the positive values and negative values, depends upon the values we can classify as causal and non-causal signals. So these are all the example problems. So what is meant by the linearity? So linearity means if it satisfies the superposition principle, a weighted sum of input is equal to weighted sum of output is called linearity signals. So if we satisfy the conditions in the sense, that is called a linear signal. So likewise we have to classify. This is an example problem. So y of n is equal to n x of n plus c. If you put that superposition principle in the sense it satisfies, that is called linear. Otherwise it's called non-linear. In this problem it not satisfy, so it's called a non-linear. So likewise we are having so much of problems. So but in this problem we are going to see about that various time invariance and variance signal. So what is meant by the time variance and invariance means y of n comma k is equal to y of n minus k, in the sense it's called time invariance. If it not satisfy the sense, it's called time variance. So likewise we are having the problem y of n is equal to x of n minus x of n minus 1. So in this problem, we are now it's not satisfying that y of n comma k is equal to x of y of n minus k. So it's called a time invariant. So likewise, we are having the so much of problems in this example problems. Likewise, we are having the energy and power signals. So x of n is equal to 3 by 2 power n u of n is equal to, what is the condition for energy signal? E is equal to summation infinity n is equal to minus infinity x of n minus x of n modulus of x of n the whole square. So what is the power condition means? P is equal to limit n tends to infinity 1 divided by 2n plus 1 summation n is equal to 0 n 1 divided by 4 divided power n. So if the energy signal is in the sense power is equal to 0, then a power signal means it's called energy will be infinity. So likewise we have to put the conditions in that problem and we have to find the energy or power signals. So what is the concepts of quantization and Nyquist theorem? So what is the concept behind the, what are the types of quantization? So up to this we have completed the types of signals and the types of systems. So in the following classes we will see the quantization. Thank you.